barely understood it when I first built this. I can share my crib sheet with you. It's a whole bunch of analogies for linear algebra stuff that I forgot right away. But it's not necessary to understand what we're doing here, and it's not really the point. So if you're expecting a deep dive into fluids math, I'm sorry. It's not an intro to GLSL either. If you went to Stan's talk this morning, that was actually a good kind of, like, he went through a lot of stuff that I thought, and Stan, if you haven't taken Stan's courses, he said it this morning. I really recommend you do. I did it. They're great. But we're going to be talking about GLSL TOPs specifically. I don't think TOPs if I do that. Okay. The assumption is you're going to know a little bit about GLSL. You're going to know a lot about TouchDesigner, a little bit about TouchDesigner, and you want to know how to get the two of them together, specifically to do GLSL top stuff. And GLSL tops, all the tops are GL shaders underneath. A lot of times people will ask things on the forum like, how do I sum the RGB channels but leave the alpha channel intact or whatever. That's a great, that's a real good hello world for GLSL in TouchDesigner. This is a little beefier one. I'm going to go real quick. What's going on? If I hit the arrow key, typically I get the next slide. Let's try this again. I thought I was going to do the whole thing in front of you. That was foolish. Instead, what I'm going to do is just go through some gotchas, some how-tos, some best practices, all using already functioning Navier-Stokes fluid advection algorithm for incompressible fluids as a hello world. I'll post it till we're done, but Kurt Kaminsky and Vincent have both posted pretty much the exact same thing on the forum. So if you want it right now, please feel free to help yourself. Mine's not a lot better. I do have some stylistic things that, one of which Stan mentioned this morning that I'm pretty dogmatic about that maybe you want to use my version. Okay, it's going to be really fast. Lots of it's going to be wrong. Feel free to shout things out. Thank you, everybody, for coming. Thank you, Derivative, for TouchDesigner and for having me. Hold on your butts. Okay. TOPs are good for using the GPU to do math. You can store information in color, floating points, the same way you would do it in CHOPS. 32-bit is floating point math is available to you, massively parallel on your GPU. The better the GPU, the more math you can do at the same time, as long as you can find a way to shoehorn it into color texture. GLSL TOPs run compiled code. That's an important thing to think about. Because as you write this code, you might get errors at compile time, not just at runtime like you would in Python. So the way to find out, may need a few things, like an info dat. They're not optional. When you drop a new GLSL top, you do not get an info dat. I don't know why. You should, because unless you're Stan, you're going to get errors as you're going, and you're not going to know what's going on. So immediately what you want to do is, as soon as you drop a GLSL dat, is drop an info, GLSL top, drop an info dat, connect them, boom. Now you can see what's going on in there, seem to be all right, and you can dock it. So I can dock this, dock to this guy, and then now he's in there. You don't have to dock it though. Whoops, that's a compute shader. Well, you get the idea. I lost it. There it is. Okay, pixel shader back. Okay, that's right. Okay. What else? Uniforms are for value input. So if I'm trying to get from Chopland in TouchDesigner, I don't even need a constant. You know how this works. Vectors. These vector tags are where you can pass in what are called uniforms into this. So I might say U color, and in here, if I'm editing, oh, no, this is GLSL, that's great. Okay, so I have a uniform example flow. Let's just use the one that we have here. Example uniform. Get this into a window. There we go. There we go. Okay. So I want to declare this example uniform. I'm going to get this in my TouchDesigner context, and I'm going to get it into my code context. And then what I'm going to use is this example uniform. I'll stick this into a vec4 called color, and this is getting assigned to my out color. And away we go now. If I'm using this one that floats up and down, right, I get my color out. Okay. When shit gets deep, you got to use the whole vec4. Stan mentioned this. Believe it or not, if you're doing a whole bunch of math in a single top, you're going to go through all these vectors. You're going to go through all three. You only get 3 pages of them. Seems like a lot. I think that's 30. You can fill it up pretty quickly. So the trick that I like to do, and again, this was mentioned earlier. I believe I have this somewhere as an example. Force, bias, and scale. So I have these 2 parameters are going to be unpacked to a vec2, which means 2 values together in a vector expressing, in this case, x and y values. and then I have a bias and scale. So I'm sorry, these are two vec2s. So if I look into the code for this guy, and I'm going to get to this in a second, but all of my code actually lives in a single giant place. But U force, bias, and scale, I've made myself a note here. The XY bias and an XY for a new force are stored in the XY and the ZW, or the AR, or RG and BA, or however you want to swizzle that. And then when I go into my code down here, I'm going to unpack those to be the appropriate things, which I'm trying to find here. Maybe I recorded them in one of these methods. But basically, you're going to unpack out the values, and that becomes necessary as you start to really fill up like a whole bunch of vectors. It can also just be a stylistic thing for you to help keep track of related uniforms headed into it. You'll also notice that I have a stylistic thing that I use the designator U for a uniform headed into the code. That way, when I'm getting into larger and larger code bases, I can distinguish uniforms from, let's say, outputs, or from variables that have a scope declaration that's limited to the inside of the code somewhere. So that tells me that stuff is coming from outside. Lay out your outputs. Okay, so you can see right here as an example, I actually don't think I have many shaders that have multiple color buffers, but I can just give you the example here in my little scratch shader. You can, I think I already have this open, yeah. So this is declared this way, but you can actually say layout, location equals 0. I think I need an out keyword. Yep, get it. Out vector frag color. Okay, so I got that. Now I can have another one. I can have many, and this is actually limited by the top, which I'll show you in a second. But out vec4, and this is a stylistic thing that I like to do. I'm going to call this O frag color, and I'm going to do this here again so that I can keep track of what's going on in my code. And I'm going to say O second color. And now I could do something where I say, let's say O second color gets TD output swizzle. We'll talk about built-ins in a second. Color times 0.5. And I need a semicolon. And now you can see that if I take the primary output of my top, I get the first color buffer coming out. But if I want to access that second color buffer, I'm going to do a render select this, and connect these two here. You're complaining because, let me go to my slide because I prepared a slide for that. Whoops, slide please. Hello. You may have to raise the number of color buffers. That wasn't really a great payoff. I did make the slide. So if you go over to the common, oops, not the common tab, GLSL, number of color buffers, I'm going to say 2. And now this, when I drop a render selected, is conveniently automatically set to color buffer index 1, which by 0 indexing is your second color buffer. And you can see in this highly unhelpful example with this color, I'm going to give it a, there you go. So now I'm getting that second color that I did in the shader here. So you can write out to multiple colors. Where's this useful? If you're doing math that has multiple results, parametric math, if you're doing stuff like deferred rendering, you might write out your depth to one layer and your specular to another, etc. Your UVs, etc. Okay, that's a 3D context. We're talking about math. Here we go. Defines just get replaced. This is true across C-style languages like this, but in the case of the way I like to use this, you can see that I'm using these defines here. Now, what I mean by defines get replaced, after the compiler directive define, hashtag define, the second word becomes a reserved word, essentially, that anywhere it is seen in your code gets replaced with the following symbol or groups of symbols. In this case, anywhere I write velocity, the integer 0 will be compiled into the code, not at runtime, but at compilation time, completely replaced. I could actually put a code block in there. I could put in really commonly used declaration, structure, whatever it is, something that I'm tired of typing everywhere. If I want to clean my code up, I can put a long thing in there, and that will get replaced anytime I put the now reserved word in there. The way I like to use this, and this is hard to present out of order in a way, but the way I like to use this is to allow me, maybe this function is not the best example, here we go, to put my code elsewhere and then use these defines to make all of my mains a single function call with really readable arguments. So I'm going to advect my stuff by my velocity. I have another advection for advecting my velocity by my velocity, and that one would say advection to velocity, velocity. And I have this O advected quantity. Look how nice and clean this is. And you can't tell what it does because the code is somewhere else, which I'll get to in a second. But using these defines lets me scan through all my code really quickly and see exactly what I've done without being like input 1, input 2, input 3. If you've written a particle shader, for example, in a top, you know that you've got like, sometimes depending on how many things you're dealing with, if it's gravity and thermal advection, you got a million things, you're going to have like 8 inputs to that thing. And going ordinal 0 to whatever, coming from a bunch of nulls that are all called null, is chaos. You're going to be like literally counting your connections going into your top, and it's a wreck, and it's not what you want to be doing at the time. So if you call your nulls on the input, this is a null that I've called velocity. It happens to be going into both of these here, but this technically should be velocity, velocity, but I've connected to the same to both of them. But if I look at my advection for my stuff, here we go, I'm advecting stuff. I'm actually adding stuff. I don't know where my advection for stuff is. Here we go, advect stuff. So this guy, I'm advecting my velocity by my stuff, which is input 1 is my velocity, and input 2 is my stuff. Don't worry about the velocity and the stuff part. The important part is the defines make it really easy to read. And again, you can see all of these things are one-liners. And you might be thinking, where's all the code? Consolidating code. Okay. I really ordered these pretty well, actually. Okay, so where's all the code? It's over here. Somebody asked a question about includes or imports in GLSL. It's not happening. But as Stan mentioned, there's a merge, which is close. He did mention a caveat, which is that if you get an error, your line numbers are bunkum. And the real challenge is that any of the boilerplate code that you're always going to include in all of your stuff goes above, it's a C thing, it has to go above your main, right? If you're anything you're going to call has to be further up the chain. So your line numbers really get borked as you start throwing stuff in. But if you can tough it out and figure out where your problem is, this is really nice. I always throw these conditionals in. This is a point of controversy. It's ongoing. I think NVIDIA is trying to optimize this stuff out. But if you look at this URL here, it's avoiding shader conditionals. I always throw these in. These are, they return booleans, essentially, instead of conditionals. So you say when equal X and Y quantities, they're optimized for, or they're set up for vec 4, but you can use them for float. I made overridden for float and stuff like that. But you're going to get a 1 or a 0 out, and you got to rework your logic. Instead of using the conditional, you would say, let's say I wanted to add 5. I want to say if this X is greater than Y, add 5 to X. And instead what I would say is X plus equals 5 times the result of this when greater than function X and Y. And that's going to return a 1 or a 0, and I'll either add 5 or 0. The only time Elders pointed out that doesn't really make a ton of sense is if you're discarding a fragment, which is a little bit of a deep cut. But other than that, this might be a good idea for you to do because it might optimize your code on some GPUs. And the only way to figure out whether or not it does is to benchmark it. And I haven't the time. But apparently I have the time to try doing that stuff, which can be a real head scratcher sometimes. It makes you feel really smart. These are also utility functions that I like to use a lot. This is just for sampling from your neighbors, and I'll get into what the difference between a texture sample and a texture offset is. But, okay, so this is all boilerplate code. Everybody loves a remap. Got to have that in there. So I always throw these in, and these are getting merged in above, importantly above, my body of my code. Yeah, I know I heard. Take it easy. Okay. That's GLSL. This project predated the very helpful auto naming. There we go. Okay. So here's all my functions actually, and you can see that these are expecting integer inputs, velocity and stuff inputs in these cases. And that is the define that I was using in my mains earlier. So I can then sample from whatever my designated inputs are. And these are portable. It's essentially like passing around self in a class or something like that. These make these functions that I can use elsewhere and just call them with inputs, and I have these single line mains everywhere. Okay, so I'm consolidating all my code like that. This all gets merged into a DAT that then I select all over the place. And I made myself a little base that takes my main. This is kind of a big main. Let me find a small main. Here we go. I've got this little main. It's got my defines, a little note to myself. And it just calls the function, and inside you can guess what's going on. I select it, and I merge it with my main. Off we go. So while this little trio kind of bothers me a little bit, it's a little big, what it does allow me to do is have all of my big stuff, all my logic, in a single DAT that then I can save out and check into a repo and blah, blah, blah. Some of the other details of the implementation in the TouchDesigner environment are not things that we can check in at the moment, but that's nice to have. Okay. Someday, the down button. Okay, pixel formats are important. Boy, are they. If you are creating a shader in which you expect to have a negative quantity, you are going to want a floating point pixel format. Currently, it's set to use input, and if there's no input, it will default to 8-bit fixed. That will not get you a negative value. Like, for example, if I were to go into this code and say negative color times 0.5, I would expect that value to be based on my vector. 1, I would expect it to be negative 0.5, but in fact, if I hit A and then I hit D, I can inspect the value of pixels here. They're all still at 1. I hope I did that math right. So let me see, if I, oh right, yeah, second buffer, thank you. Okay, so if I switch this over to, let's say, 32-bit float should be fine, but let's just do a 16-bit RGBA float in case I get confused later. Does anyone see it? Oh, there it is. Okay. So now if I go in and do that same thing, hello, D. No, I messed something up. Oh, I did it on the wrong buffer. I see what you mean. Save. -1. Right, so that's the only way you're going to get negative values if you have a floating point pixel format. Big gotcha. Another thing is that you may be dealing with negative values and you cannot visualize them. If you're a visual person, you're doing a lot of math in the context of the top, you may find yourself scratching your head and saying, I have this thing that looks extremely dark, but if I go and I inspect, I can see that there's these negative quantities in here. Oh, it's kind of low on the screen, I see. Let me get this over your heads. Here you go. So you can see the R value is negative here, and this is a quantity that I'm using to store velocity. And the R is my X, so I have negative velocities that are in your directions going this way, and I have positive velocities pushing this way. I have positive velocities in the Y, or the G value, and negative in the G going down, which makes sense. I'd use a floating point pixel format for that, but I can't see it. So really simply, you can just rearrange, and this is a case where that remap function would be really useful. I have this display vec2 function that I've written, and if you want to look at display vec2, I actually have no idea where it is. Aha! In value, I'm just going to sample my texture. I'll talk about this in a second, but we're just going to take a sample of that exact same pixel on my input, and then I'm just going to use bias and scale to rearrange that into something that I can see, and those bias and scale are just going to be uniforms that I use here. So in this case, I'm going to add 0.5, and I'm going to leave the scale where it is, and now instead of having ranges that are largely negative, I have ranges that are positive, and I can actually see what's happening there. And so just so you guys know what's actually running here.
Or use the math top.
Or use the math top. Thank you so much. I probably should be doing that. Oh, okay. Okay. I often, somebody will tell me to do something like that, and I'm like, I didn't even know that existed. Open parent parameters. Here we go. Whoops, wrong parent. Let me back out of this little guy. And I'm just going to bump this, and I'm going to close this, and I'm going to open my parent viewer one more time. This is what we're dealing with. I know you guys are expecting fluid, so here we go. If I razzle dazzle. This is what's going on in here, and we'll talk about how this is put together in a second. But obviously, I have these velocities that I'm painting in here that are positive. They're going up and to the right. But if I wanted them to go down and to the left, and I was, let's say, testing the shader that I'm using to generate those velocities, and I'm like, what is going on? They won't go down and to the left. First thing I'm going to do is make sure my pixel format is floating point so that I can have negative values. And secondly, I might want to visualize it by rearranging my quantities into something where I can actually see, because this is not what's actually in the shader. What's actually in the shader is this black-looking guy here, because it's not in a visual range. This is kind of like what NASA does, you know? With the infrared, push it into the visible, same notion. Okay. There's more than one way to sample. I don't want to get too deep into this GL-specific stuff here, but as a good example, you can sample as a texture, and if you do a texture sample, which is the one that you're going to find yourself doing 9 times out of 10, you are asking for an interpolated sample at that point using the UV that you've passed in. I've got to have a texture in here somewhere. So here we go. We're going to sample texture. We're going to tell it from the from the built-in inputs, which is an array of inputs, a certain number, and then the UV that we got passed in from TouchDesigner context, which tells us where we are in the UV map. That should make sense to you. But also, let's say I see a lot of people doing conversions from the built-in uniform that tells you what the resolution of your top is and the UV to try to figure out a pixel offset and then sample that way. But there's actually a built-in that does that in GLSL. It's called texture offset. But the funky thing about texture offset is it expects an IVEC2 as an offset. It's actually not that funky, it makes sense, because you're asking for a pixel away normally. You can ask for multiple pixels away, but that's limited by your GPU, and some of them will squawk. You can ask what that limit is with a compiler thing, or some kind of uniform should tell you how many neighbors you can get away on your GPU, but it's generally bad practice. It's really bad for biz. It'll slow your stuff down. But sometimes you have to do it for blurs, any kind of kernel-based thing. You're going to need to sample away, and so this texture offset function can be really useful. You call it pretty much the same way. You do pass your VUVST, but then you need an IVEC2, and that's an integer vec2. If you try to pass that floating point, you're going to get an error. But these are, my left neighbor, my right neighbor, my upper neighbor, or my lower neighbor. Well, it's actually probably upper and lower neighbors. Okay. And I'm going to get to another way to sample. Oh, TD built-ins. Here we go. Oh, I have internet access. Let's see if I can make this happen really quickly before I lose the internets. The GLSL top documentation will tell you about some important TD built-ins. I don't necessarily have time to go through all of them, but or maybe any of them if it doesn't load. But for example, UTD2D infos is a struct. It's an array of structs. Hello, infos. Here we go. And the array is indexed by the number of the input that you're referring to, and it tells you information about the input. So it'll tell you the resolution of the input, which contains the reciprocal of the input to begin with, the reciprocal of the width and height, and then the width and height, so you can index into that with the little swizzle. And it'll tell you the depth as well if you have a 3D input. So you would look at, for example, the height by saying UTD2D infos of 0, this is your first input, getting the resolution structure, and then you're asking for the last of the vec4, which is the height. That can be very helpful for calculations where you're trying to figure out where you are. Let me see what else we need. We need UTD pass. Somebody asked about this on the forum the other day. This will tell you if you're doing a multipass shader, what pass you're on. So if you're trying to do, let's say, a progressive bloom blur, and you wanted to blur a little bit more on every pass or a little bit less on every pass, you could ask the context, what pass am I actually calculating? I'll show you what I mean by multipass in a second. It's common to all tops. There's atomic counters now. I don't know anything about it, but I'm excited to learn. I was a little busy getting ready for this. Very helpfully, there's Perlin noise and simplex noise built in. This is huge. Anybody who's trying to create noise in a GLSL context knows that you end up with these like cryptographic-looking, ridiculous munging equations that were written by like 3 people on the planet who understand them. They're built in. It's much nicer to just sample these things. Nice conversions from HSV to RGB space. Dithering in case you're getting banding on your output. If you're trying to do a subtle gradient from like 2 very close colors, you can dither. If you get close to it, it looks noisy, but if you get farther away, it doesn't look bandy. So trade-off there. And TD output swizzle, which is in here somewhere, is the recommended way to pass your color out rather than just assigning it to your out color. And that is to allow TouchDesigner to handle swizzling on the way out. Here you go. All right. I got lost. Right. We're still in the browser. I am going to scale it. That's exciting. Okay. What happened? Yes. Okay. Looping through inputs. You may find yourself, am I doing that anywhere? Looping through inputs. I know I am somewhere. Well, you could just declare a for loop to sample. Oh, yeah, I know where I'm doing it. My ad. You can loop through your inputs to sum them, for example. If you want to write your own kind of compositing that was agnostic about how many things was connected to it, you can see I'm just looping through up to the built-in TD num inputs, 2D inputs, I want the 2D ones, and simply just summing them to a destination that I'm sending out. So this is just a very simple add, but you can do any kind of compositing in there, looping through your inputs. It's also probably good practice if you haven't decided how many color buffers you're going to have, or you're going to be really sloppy about writing out to color buffers or sampling the wrong number of color buffers, and then you can loop through your outputs and write to your outputs the same way. Just keep your color buffers the right number. That's probably the best idea. Feedback is key. Resetting feedback is a pain. You need feedback. This is a pain point for a lot of people who are like, okay, I have this. Let's consider this. If I dump this whole thing into one top, which you can't because of the way these calculations work, but if I was writing one top, let's say like a feedback that had a feedback on the outside, or that needed to get its own quantity back into itself, which this whole network does, you will get a cook dependency issue if you connect your output directly to your input. So in the interim, you need to hold it in a null and then grab it at the top of the chain again into a feedback, which are these green guys. I labeled them green because in the beginning I was running to kind of a pain point, which was hitting the reset. So the feedback will let you sample back in without getting a situation where you're trying to cook one frame forever. But in order to reset this network, you know, if I were to go in and just reset the velocity, I'm giving you a little color here. If I were trying to reset the velocity and then the stuff and then something else, I would never be able to get this back to 0. But if I open my parent parameters, what I've done is I've got a single button, and I made myself a little tool here that lets me reset all my feedbacks at once. So you just go in here. It's really simple. It's just an op find, which is a beautiful object. I'm going to grab all my feedbacks, and then I have a little thing that just goes through the loop and pulses them all, pulses the resets all at the same time. So you do want to get a nice simultaneous reset if you're actually doing a simulation. Okay. Multipass processing. Really simply, this is built into all tops, but it comes into play in the fluid advection. Your Jacobi pass gets more accurate, essentially, the more you run it. And so here in all tops in the common tab, there's a passes option. And so I've exposed the ability to increase the number of Jacobi iterations as much as possible until my FPS begins to drop, and then I can back it off a little bit. But if you have a shader that has an effect progressively every time, let's say like a blur, you can run blurs multiple times. Just like that. You don't have to drop 3 blurs in a row. You can just say run the blur 3 times, 3 passes, and it will essentially handle its own buffer. It'll say, okay, I just did it once, put it back in the beginning, run it again. Okay. Accessing chop data is done in GLSL via sampler buffers. Oh man, I made a layout for that. Where did it go? Okay, let's see if we can find this thing. So Stan actually just did some stuff like this, but basically, one way to do this is I have some data that I want to get in here, and it's going to draw these circles for me, right? And I'm just, they're just patterns, whatever. But I could do a chop to top and then sample that in the same way that I was doing with the texture or whatever and get the quantities in that way, but that's an expensive step that's not necessary. I can actually just drop this in as a vec4 texture buffer, and again, I've declared that as a uCircle array, but if you go in here, I've actually declared it as a sampler buffer in the code, and then I sample it using texel fetch buffer, and I index into it with that is the sample index. So I have 20 samples on this guy, right? And so when I do this loop, I'm actually going to run this 20 times, and I'm going to sample every sample in my buffer, and because it's a vec4, I have 4 channels in it. My 4 channels are going to be my vec4 swizzle. So X, Y, Z, W, RGB, A, whatever you want to do. And that allows you to dump in chop-based data without doing an expensive chop-to-top conversion, and without dealing with UV stuff, which, as you know, is floating point from 0 to 1, where you already know these integer quantities of your sample and your channels. It makes it a lot easier. Okay. What else? Oh, wow. Hey, you guys. I think we're at the end. I know that was really fast. Sorry. I was worried that I was going to run out of time. Are there any questions? Questions? Do it again? Double time? If anybody wants to play with the fluids, I mean, you're welcome to come do that. Maybe I should leave Prince up just for the remaining 15 minutes. Sorry, now we have dead air. Question? Yeah. Oh, sorry.
Yeah, so this is all wizardry for me, but as I come to understand, you're using the GLSL shader to store different data than as opposed to visual data.
Exactly. Yeah, so the question was, is the shader's not necessarily working with an image, it's working with data. So just to slow down a little bit and look at the premise here, this channel is just, if I look at the pixel format, it's just RG and it's 16-bit float. This is my velocity quantity, all right? So at any given moment in this execution, there is a velocity quantity. In the Navier-Stokes fluid advection algorithm, you process your velocity and your stuff, and the velocity gets processed into pressure, and then you got to get rid of the pressure by moving the stuff and moving the velocity until there's none of it, and then you can start over. So this velocity quantity, if you're looking at it, I'm going to bring up, okay, so you see how this stuff is going up over here on the side, and it's going up over here, and it's getting pulled down. I'll show you why that is. here on the right, you can see that the green channel, RG, G is my Y, X, Y, is positive, and if I inspect this by hitting A and then hitting D, you can see that I have a positive value in the G. It's like 0.1 or something like that. That's force going up. If I go down here in the middle, you can't see it, but if I use that shader that we looked at a moment ago, you can see that the quantity is going down. If I were to rearrange that, that would have value. It's just not in the visible range right now. So that is a quantity that is data. It's not meant to be looked at. I mean, there's nothing wrong with looking at it. It looks nice, but it's not the end product that I'm after. What I am actually moving around is my stuff, and this is my stuff. This is the thing that we can see, but this also needs to be treated essentially as a quantity as well, because the metaphor and the reason that the fluid algo is a great hello world for getting started with GLSL TOPs is you're dealing with stuff as data. The visual product in the end is the data, and you paint in force, in this case for a physics simulation, with color. So when I'm clicking and creating force, like just as a baseline, what's happening here is I'm adding in this rotating blue triangle of stuff, but also here, you can't see it, but I have this triangle. This is another triangle. You can see that the sides are set to 3, and if I change the color, let me see if I can get the, hello? Where's my viewer? Open parent viewer. So it's open, yes. Okay. So what I can do, can I just please hit the corner? Oh gosh, oh gosh, okay. Oh, look at what I did. I had a viewer set up for that. Sorry. Okay, one more time. Right. So this circle is creating a downforce right here. If I were to change this to a positive value, you would see that the convection, after a moment, would start to head up. Because I'm painting in this circle, and if I made this a larger quantity, it's going to break a little bit because it doesn't like to move too much in every step. But you can see that I have this positive G value. And that positive G value is a positive Y value of force that is being painted in. Another fun thing to think about is that ink itself, or stuff, can be a negative value. So what I'm actually doing, you can see, is this triangle here, there's another triangle, is sucking out RGB. It's a black hole. Just a little bit, not a lot, but everything that passes through it is actually getting subtracted in color. A little bit more like ink than RGB, or additive color, like the way you're used to it on the screen. So you can paint with ink because you're dealing with color as a quantity in a way, in a floating point way, where it can add or subtract in a given spot. I probably should have started with that. Great question. Yes?
Maybe TouchDesigner needs better visualizers for data as opposed to color. I mean, you just pointed out how you wanted to normalize -1, +1, visible. Things that are x, y velocities, you may want to have as arrows, you know, like arrow field or something.
That comes up on the forums all the time. Optical flow.
Okay.
Yeah. Vectors.
Reading the forum.
Yeah.
Other things that might be useful for visualizing data in TOPs?
Well, so you have, to your point, you have auto homing for geometry.
Yeah.
A normalizer like that would be really helpful. I mean, you're going to have to track the range. It's going to become inaccurate.
Pull up the math top.
Yeah, there's a math top.
Auto range.
That's math. Oh, goodness gracious. Math top.
Yeah, so it has a range thing back there.
Yep. That would be helpful.
But the auto range is sort of what you're after.
Yeah.
Yeah, okay.
That'd be nice. Oh, now there's a mic.
My questions too late.
Yeah.
Thank you, Marcus. Thank you.
I'm going to have to inspect the math top. I flat out didn't know that existed. Any other questions?
Yes, John.
Yes.
Anything about the algorithm you guys using? That's a great one. Anything about the algorithm you guys using? Looks like a grid search, so you only do
So the way this particular algorithm works is it's grid-based. So a grid in this case is the pixels. And the grid doesn't move, the quantities move. And so that advection term is actually to reach a time step ahead and move the quantities where they're going to be in every time step. And this is another thing that's kind of interesting if you're doing like physics simulations. It's not super specific, but you might want to access your actual time step, which is a fraction of your FPS, to do your calculations. If you want to have a time baseline that you're doing calculations based on, like if you have constants like gravity, for example, is 9.8 meters per second, if you want to know what a second is in the context of your your algorithm, you're going to want to know what rate your simulation is running at. Elbridge and I actually were talking about this yesterday too. I believe it was Vincent who pointed out to me that if you're doing a simulation like you're writing your own particle system and you're doing collision detection in a naive way, which is to say you're just like, if on any given frame, if my particle is like intersecting this other body, if the particle is moving fast enough, over the course of a single frame, it may actually pass the border and be inside of the boundary. One trick is you can overcrank your physics. So you can go into your physics simulation, go to that passes tab, and crank your passes up as far as it'll go, so that within one frame you're actually running your physics many times, but then you're going to want to subdivide your time step in a way that rescales all your constants that have anything to do with time, because everything will just start zipping around the screen. Super sampling, which is a fun term. Anything else? I got to clean this up, but I will post this if you were hoping for fluids. I try to make this something that's like kind of usable in terms of there being really clear kind of inputs where you can like add stuff and add force and things like that in a really kind of clear way. So if you don't really want to dig into the math, which I wouldn't blame you, you can just treat this as a widget. These fluids are fun. I do have some boundary stuff that's going on that's not entirely copacetic. I was really proud of myself that I implemented all the boundaries without doing any conditional, so it actually recognizes whether you're on the edge pixel without doing an if, but that's probably the better way to do it, to be honest. I don't think you would notice a hit on like a 10 series processor. Yes, sir?
Can you do boundaries as a texture input?
Yes, the question is, can you do boundaries as a texture input? And the answer is yes. The challenge is, typically what you want to do is, and Bo Burrows has a shader that does this, and I didn't steal it from him when he flashed it at me, but he found it somewhere else, so I think he'll give it to me. But basically what you actually want is a shader that finds the centroid of an arbitrary region in a top that's defined in a top. Let's say you drop in a square, for example, but really more likely in the context of what a lot of us do, you'd have like a silhouette of like a human being. That is this really kind of arbitrary region, and what you want is everywhere in the upper portion of this thing, you want vectors that are pointing out. You want a y vector that is pointed up, and you want, on the bottom half, you want y vectors that are pointed out, and on the sides, you want vectors pointed the other way, so that if your particle skips in, your particle in this case being stuff, skips into a collision boundary, into an obstacle, and it's inside, we don't have, in the context of GL, the ability to go back in time, essentially. We have no knowledge of any frame of operation outside of what we've done, unless you want to store like multiple caches, and that would be insane. So you do want to be able to account for situations where you've gone into the body of some kind of obstacle and still know the way out. Otherwise, you're going to have to destroy the particle, which is...
Make it be done.
Right, so then what you got to be able to do is take some arbitrary shape and be able to calculate the vectors pointed out from the centroid all the way around, which can be done, but I forgot to get a PhD. But somebody did it.
Is that one like a slope top?
A slope? I don't know the slope top. What's a slope top?
Bring it up.
Okay.
It's normal. It's like the slope, the waves change like the pixel.
Oh my goodness gracious.
Put
So
it
if I-
on your image right there.
Oh yeah? Okay. Put it on, where's my stuff? Where's my stuff?
But it's, again, it's pixel by pixel. So it doesn't-
Pixel by pixel. I see. Yeah, but the center is what we're worried about here. So yes, this was, of course. The problem is so this would work as a boundary right here as long as we hit it during our calculation. But if we had a particle that was moving fast enough, within one time step, it might actually pop in past that boundary, and then it'd just be in here going about its business like it's allowed to be in there, which it's not. So what we actually want is like essentially like a circular ramp. You know, when you do a radial ramp, that looks like radial ramp. This is what we want, essentially, only without the boundary. Maybe circular is actually what I want. Yeah, but not with, you know what I'm talking about, you guys. Yeah, so this is what we want. So we want everything pointing out in RG, or B, if you have 3D, which is the exact same thing, just with the third dimension. There is a way to do it. I don't even know what it's called, so I haven't been able to look it up. But I've banged my head against this a whole bunch. That's why I don't know.
Did it affect stuff constantly, or is it just when the simulation is starting?
The question is, does it affect stuff constantly? I think the question you're asking is, why does it start moving right at the beginning? Is that what you're asking, maybe?
No, what I'm asking is more about But how would you go, because this is like an object within alpha, so it has a negative space. But how would you go about affecting like a full picture constantly, like a video?
So I'm going to answer a slightly different question that I think is going to get you closer to what you want to do. The question is, how could you advect a whole frame of video? If I put an image in here, like let's say like a banana, we're dropping a banana here instead. I actually want it to be on the first input of this. This is going to be a real pain. Let me just swap these. Okay, there's my banana. And now if I, my parent parameters, and I bump this thing again, there goes my banana. Now I do have the triangles in there, right? But the banana's gone now. The question is maybe, how do I keep the banana around and still have it look like I'm on acid or something? Somebody on the forum did a great example of this. They made a sprinkle shader, and basically stochasticity is used, like randomness is used on every frame to decide whether to drop in one of the pixels of the original image, sprinkle them in so that the image is persistent, but it's also smoking and going away. Because if I just leave this image in there, it's gonna flood this fish tank with yellow. There's also, just really simply, you can just dissolve away your stuff, whereas dissipation. So I could set my dissipation to like 0.97, and the tank would be significantly less busy over time. That's my velocity of dissipation, sorry. But that's just basically, I'm just scaling it back out. There you go. So now I've got like a really limited kind of.
And how would you go about time steps? Because you have one frame every frame, but you're actually affecting way more time. So you start extending that. How do you
Yeah. Yeah, that's a great question. The question is, how do you avoid this steppiness that I'm getting? Like if I give too much velocity to any of these things, you can see there's like a kind of a shredding that goes on where you can see the time steps in here. You see the outline of the triangle going away? You would have to overcrank the entire simulation. But my Jacobi iterations are set to 50 now. I would have to concordantly take that down or my computer would light on fire. But I do think that you could go in and overcrank all of your... Nope, that wouldn't work. I actually don't know.
Mask it with blur?
Yeah, it's blurred. I actually don't know, because you can't. If you overcrank each shader, it's going to run its process more than once, which doesn't make any sense. That's the problem with this whole thing. Is that the first thing I thought was like, I'm smarter than everybody. Why don't I just write this whole thing in one shader and just pass the results of each of these operations out? But that's not the way these operations work. They have to write out to a new buffer, and then that's got to go into the next one. If you try to run this all in one shader, it's way too much math. You actually need to be doing these all at the same time and passing down the line. Temporal subsampling. Yeah, so if I understand what you're saying, I think that would be overcrank. That would be running multiple passes on one shader within one time step. But we need to run this entire operation multiple times per time step, which would require us to get all of this into a context that can be executed more than one time per frame, which I don't think the abstraction exists.
I'm just thinking, what if the timeline was set to 240 frames per second,
Whoa.
but you only displayed one out of 4 or something like that?
Wow.
I
I was told it was a no-no, but hold on to your butts, as I said earlier. Let's see what happens. So I can't even change the FPS. Bottom left. I never do it. It's because it's a no-no. I'm going to do it. But hold on, guys. Here we go. Let's see what happens. Right, and then I would be displaying fewer frames. You know what?
You may have an issue with the vertical sync.
Oh, this is G-Sync, baby. I'll do whatever I want.
Did you turn it off?
I did turn off G-Sync. You're right. Still though. Yeah, we're still at 60. Well, hypothetically, that would be really cool.
Maybe we'll tweak something so it's possible.
That'd be cool.
But like if you're drawing one out of 4 frames, you would use your interface that you could simulate faster.
I would like that, because these are all split up and I can't use the passes thing.
Yeah.
Anybody else? All right. Thanks for your time.